In this video, we are going to go over how to graph a very special form of a linear equation, one that you're going to use again and again and again in math, all the way out through calculus. You can actually use this idea. Let's not use those big words like calculus now, though. Let's just jump into slope-intercept form, which is the form of a linear equation. It will form a line, y equals mx plus b. What is m? What is b? Well, m is your slope, as we've talked about in previous videos, or your rate of change, the same thing. B is your y-intercept. What is the y-intercept? We will see that very shortly, but I'm just going to kind of give you a verbal definition for now. A y-intercept, to intercept something, is to cross it, right? Cross the path of something. So it's the point that crosses the path of the y-axis. You intercept the y-axis. We use the letter b as just any constant and m as any constant. They have no significance beyond that. Okay, now from here I'm going to show you why the process of graphing y equals 2x minus 3 can be easier than just plugging in numbers. So I'm going to show you why the process works by plugging in numbers and going over, well, basically slope, rate of change, and plotting points that you've done before. And then from that we'll see that there's a shortcut. In a later video, I'll exercise this shortcut, this process that you're going to want to get down and get down well. Okay, let's do it. So in general, remember that if I have a linear function, or any function for that matter, I can plug in values to get out values to get points to put on a graph. In other words, let's pick some x values to put in to get y values. I'm going to just pick 0, 1, 2, and 3. And I know that I've sometimes picked -2, -1, 0, 1, and 2. The reason why I'm doing 0, 1, 2, and 3 in this case is I want you to be able to more easily see a pattern. And I think that'll be better shown with 0 and then some positive whole numbers. So all we're doing is plugging in 0 here. 2 times 0 is 0, minus 3 is -3. So I've plugged 0 into this function. I'm going to take 1 and plug it in here. 2 times 1 is 2, minus 3 is -1. Sweet. 2 times 2 is 4, minus 3 is 1. And then 2 times 3 is 6, minus 3 is 3. So all I'm doing here is plugging in x values to get out y values. I'm not showing that work this time. That has been shown in many previous videos. Now, here's the important part. We could plot those points as is, but I want you to notice the pattern, and we're going to use that pattern to use this equation in a much more powerful way. Notice that each x value goes up by 1, and each y value on the right-hand side of this table goes up by 2's. -3 to -1 is a +2, -1 to 1 is a +2, and the space from 1 to 3 is a +2. So for every 1 additional value added to x, we add 2 to the y value. Ooh, that's what 2 times x represents. And if you've seen in previous videos where we came up with patterns, we came up with linear patterns like this for tables like that. So here we're going backwards and saying, well, the pattern is for every 1x, we go up 2 in the y direction. That's slope. So what we basically just said is the slope of this is up 2 in the y direction for every 1 in the x direction. And look at that. That slope is right here. You could put it over 1 to make it seem a little clearer. That slope is right there. So we didn't have to come up with this pattern. Our slope that gave us this pattern is right in y equals mx plus b. So part of this a lot of a quicker way of graphing y equals mx plus b, instead of plugging in points, is noticing 1, you've got a slope. The second thing to notice is this. When you plug in the number 0, if I were to plug in 0 here, 0 times m would cancel out everything and leave us with the b value. So y would equal to b when x is 0. In other words, this number right here is going to be your y-intercept every time. So b is going to be -3. If I plug in 0 for x, I get out -3. Let's now graph this information. So the idea here is that I've got the y-intercept of 0, -3. So that's 0 down, 1, 2, 3. And I'll put a big point there. Again, the reason why it's called the y-intercept is we are literally going to intercept the y-axis. Now that I have the point 0, -3 from my b value, my y-intercept, I can use my slope to move from that starting position how the slope tells me to. It tells me to rise 2 and go to the right 1. So I will do that. So I will rise 2, 1, 2 over 1. Boom. Rise another 2, 1, 2 over 1. And that's how the pattern goes. Rise 1, 2 over 1. And as you can see from our table of values, we have the point 0, negative 3. Here it is. The next point, 1, negative 1. There it is. The next point, we've got 2, 1. There it is, and so on and so forth. And we could go backwards. Instead of going up 2 and right 1, we could go down 2 and left 1. And like we've seen before, we've got a bunch of points. We technically have points in between those as well. So I am going to connect these points on the line, which is not the straightest line, and that is going to give us our graph for this equation. I hope that showed you a little bit behind the why this works. So when you're graphing slope-intercept form, you don't have to write out this table. That was just to show you why all of this works. You essentially are looking at the b value, the y-intercept, which will be the value to the right of, or even to the left it could be, of the slope expression. You know that it's slope because it's a number times x. The y-intercept will be standing alone. So we graph that y-intercept first at 0, whatever that y value is, and then we move from that point however the slope tells us to move. In a later video, I'm going to go over this process again and again and again, just so that you feel good on it. This video's purpose was to show you a bit of why that process works. I think it's so rad. I can't wait to see you in the next video so you get this down and master it well.